Good morning, friends. Let's discuss about Apache Spark. So Apache Spark is a multi-language engine. Multi-language engine means that it supports not only just one language like Java, but it also supports Scala, Python, R, SQL. So it has got multiple language engine to support for, and it's for executing data engineering, data science, and machine learning on single node machines or clusters. So if you look at it at this diagram here, so this is the complete Apache Spark ecosystem, in which we have got Apache Spark core API at bottom, which can be supporting multiple languages like R, Python, Scala, Java, and SQL. Apache Spark itself is written in Scala, so that's why it's very much compatible with Java. But you will also see like a lot of frameworks on Spark based on PySpark for Python. But in this course, we'll focus on the Java framework that we're going to use. And it also has got several type of modules inside it. For example, Spark SQL, Spark Streaming, Spark ML for machine learning, and GraphX. So the key features of Apache Spark is that if we want to do any like data analytics like SQL analytics, then we can use RDDs. RDD is the heart of the Apache Spark core APIs, which stands for Resilient Data Structure. We will discuss about this in details in this tutorial series. And Spark SQL is very much like we can execute ANSI SQL queries on this and create dashboards and ad hoc reporting. And it runs faster than most of the data warehouses. And the second module that we will discuss is about the machine learning using SparkML. Train machine learning algorithms on a laptop and use the same code to scale to fault-tolerant clusters of thousands of machines. And the third module is about the batch streaming data using Spark Streaming. The streaming can be happening from anything like Apache Kafka or just a socket stream. And from a socket, we can read all the streaming data. And it helps to unify the processing of data in batches and real-time streaming. Now, why do we need Apache Spark when we already have the whole Hadoop ecosystem already having a MapReduce software utility in that? Now, the Spark is a flexible alternative to MapReduce. MapReduce requires files to be stored only in HDFS. This is a very important point. It only supports the HDFS, which is the Hadoop distributed file system. While Spark can work on data stored in a variety of formats, not just HDFS, but it can also have AWS S3 bucket, Cassandra, Mongo, HBase, or normal SQL, PostgreSQL, MySQL, anything. So it has got a variety of formats which it can load the data from and work on that data. But MapReduce has got a limitation that the files has to be stored into Hadoop file system, HDFS. Also, Spark can perform operations up to 100 times faster than MapReduce. Because MapReduce writes most of the data to disk. Now here the disk I/O is involved when we are dealing with MapReduce, and which always has got more latency than the memory I/O. So MapReduce writes most of the data to disk after each map and reduce operation. However, Spark keeps most of the data in memory after each transformation. We know that memory is definitely faster than the disk I/O, right? That's how the Spark is said to be like performing faster than 100 times faster than MapReduce. Spark will write to disk only when the memory is full. There are a lot of configurations possible in Spark by which we can tweak around whether we want to store in memory, and when the memory is full, what to do next, how much data to replicate to, an example, which we'll learn in our future chapters. But the essence is that Spark has replaced MapReduce because of the performance thing, and also the wide variety of data formats it can read the data from or work the data with, not just HDFS. So after we have covered this chapter on Apache, we have given a very high level of Apache Spark. In the next video, we will cover the cluster mode overview, in which we'll dig deeper into Apache Spark overall architecture, and we'll discuss about this cluster mode. So see you all in the next video.